When two carbon atoms are connected with four groups which are the same, this creates something called stereoisomerism. So, what does that look like? And what does that mean? So, that is what we're going to be talking about today in this video. So, first of all, if we want to know about stereoisomerism, then we're going to have to learn about two different concepts. That is superimposable and non-superimposable. So I'm going to be showing you this using a molecular model. So for that, I'm going to use carbon, and I have a bit of a sheet right here which can help you understand the video. So we have carbon, and I'm going to join that with four different bonds. So after I do this, I'm going to start to connect these with hydrogen, bromine, fluorine, and lastly, chlorine. So now what I'm going to do is I'm going to create a similar compound, and you're going to find out what the difference is. So again, I'm going to use four different bonds, and I'm going to connect them to the carbon atom. Then I'm going to use a fluorine, a bromine atom, a hydrogen atom, and lastly a chlorine atom. So if you look at these two, you can see that we can get them to look like a mirror image, because if I put this in front of this, then you can see that they look pretty much like the mirror opposite. But if we try to match them up, it doesn't work, because the fluorine and the hydrogen, they line up, but the chlorine and the bromine don't line up. Similarly, if I try to get the bromine and the chlorine to line up, okay, so over here I have the fluorine and the chlorine not matching up, but the bromine and the hydrogen are matching up. So now if I'm going to move two atoms, and I'm going to change their orientation. Now over here I have something which I can get to line up. So over here I have a hydrogen, the fluorine, the chlorine, and the bromine, and they all line up. So in the first example, when they didn't line up, but they were the perfect mirror image for each other, like this is called a non-superimposable mirror image, because you can get them to mirror each other, but you can't get them to line up because two of the atoms won't line up. But what if I do something different to this? What if I replace the fluorine with hydrogen in both molecules? Well, now over here you can see that I can get them to line up. I can get them to be the perfect mirror image for each other, and I can also get them to match up, meaning they all align and they are the same molecule. So this is called a superimposable mirror image, because it can be the mirror image of each other and it can also line up. So this is called superimposable. Now we're going to finally talk about stereoisomerism. what is stereoisomerism? Stereoisomerism is when a molecule has the same groups or the same atoms, and they consist of the same, well, atoms. So over here, we have our molecules, and they both consist of the same atoms, which is bromine, chlorine, and hydrogen, and carbon. So I'm going to go back to our original example where we had 4 different atoms, just so this can be more understandable. Over here, they do not, they do mirror. They are non-superimposable because I can't get them to line up. So over here they have the same atoms. They consist of the same things, which is carbon, hydrogen, chlorine, bromine, and fluorine. But they don't line up, and that means they don't have the same orientation because I can't get them to line up. So this is called a stereoisomer because because they do mirror, but they are not the same molecule. So if I did the same thing over here, except replacing the chlorine with hydrogen, this is not a stereoisomer because yes, it does mirror, but they also line up perfectly, which means these aren't isomers for each other. They're the exact same molecule. But in our previous case, when they did mirror each other but didn't line up, that was a stereoisomer because, well, they mirror each other, but they don't line up. So thanks for watching this video, and I hope that you're going away with a bit more knowledge about stereoisomers. Thanks for watching, and be sure to like and subscribe.